Hello, my name is David Capobianco, and my presentation is on plasma propulsion. So we'll go over a little history of plasma propulsion. Plasma propulsion, which is known as electric propulsion, has been around since the 1960s. The technology was experimented for use in aircraft propulsion, but since the thrust to energy ratio is too small, it didn't show much promise. This technology is, for the most part, wasn't used or well known until the recent decades due to the rise in demand of space travel. Today, there are a few hundred plasma thruster being used in commercial communication satellites. Um, since the implementation of plasma thruster failed to make any promise in aircraft for application inside the Earth's atmosphere, so what changed? The biggest is the use for space where there are no friction or drag forces. For the application inside our atmosphere, the thrust required to keep an aircraft in the air will take so much power that the size of the battery will be far too heavy. The space in space with no counter forces, only a small amount of thrust force is required. This force will add up over a long period of time to produce a high velocity. Chemical thruster, which is the standard propulsion method today, produce a lot of thrust for a short amount of time, but the fuel is expensive and heavy, and it does not last very long. The chemical thruster can overtake plasma thruster at the beginning of the race, but since the fuel runs out very fast, plasma thruster, on the other hand, can produce thrust that lasts for could be up to years, depending on the fuel and energy source, and will overtake chemical thruster if given enough time. To put into context the advantages of plasma thrusters, a trip to Mars, as an example, will take a chemical thruster around 6 months to complete, where it would take a plasma thruster only 39 days to complete. There are many types of plasma engines. The first type is the Helicon plasma thruster, which use low frequency electromagnetic waves to propel ions. Another type would be magnetoplasmodynamic thrusters, which use a force resulting from the interaction between a magnetic field and electric current to generate thrust. Then there are pulse-inductive thruster, which is like magnetoplasmodynamic thrusters, but they do not use electrodes. The next type is electroless plasma thrusters, which use a phenomenon called ponderomotive force, which acts on any plasma. Lastly, the most famous would be Vesemir thruster, which use a magnetic field, then accelerate the plasma out of the engine, generating thrust. These are the types of thrusters today, but more types are still being developed. The thrust or force provided to an aircraft result from the ejection of propellant from the engine exhaust into space. The thrust is the time rate of change of momentum of the propellant. Due to the time constraint and keeping this video short, I will not be going over equation listed, but use it as a reference to better understand the physics of thrust. In chemical propulsion, the thrust result from the combustion of propellant in a chamber, which then expands in a nozzle. The exhaust velocity of the ejected neural particle depends on the propellant molecule and chemical properties on the engine expansion ratio. In electric propulsion, or plasma propulsion, the thrusts result from ejecting charged particles. The motion of a space vehicle is governed by the law of action and reaction, or momentum conservation principle. The acceleration is created by the expulsion of a propellant mass, and an electric power source is used to create and accelerate the charged particles. The thrust is order of magnitude lower than the chemical rocket, as the propellant input is limited by the discharge characteristic. An electric thruster typically comprises of three components or regions. The plasma coupling region, the ion extraction and acceleration region, and lastly, the ion beam neutralization and detachment region, or sometimes called plasma plume. The last two are often defined as the thrust exhaust. The main distinction between a gridded ion thruster and plasma thruster is used for electrically based multi aperture grids for the extraction acceleration of ion beam, which then has to be neutralized. Gridded ion thruster and electroless plasma thruster can be classified by their dividing frequency, which involve various power transfer mechanism to the electrons. Let's talk about the space application for plasma thrusters. Due to their low thrust range and vacuum requirement, plasma thruster can only be deployed in space. They can be used as a primary or secondary propulsion engine and application like satellite station keeping and deep space exploration. Requirements vary depending on the types of maneuver to be executed. For future missions such as deep space exploration, the power requirement for a fixed payload mass simply scale with the distance. This power cannot be achieved by solar electric conversion alone in this case. That being said, for applications such as low Earth orbit, plasma thruster could last indefinitely due to the limitless sunlight and air particles as matter to eject as fuel. Typically, the path for a new spacecraft thruster from initial concept and research to commercialization and a space mission is costly and include experimental and modeling studies in a laboratory, which is a factor to keep in mind when trying to project and predict future technology, time frames, set, and etc. Um, so advantages of combustion thruster. Combustion thruster have many advantage and should be acknowledged that it is the main type of thruster used today in space mission because of the reliability of this technology. That being said, it seems that this technology has hit its apex and no new discovery are projected to surface for combustion thruster for the next 20 years or so. Combustion thruster also have environmental impact concerns which give off many greenhouse gases when it is in use. Lastly, combustion thrusters are heavy and need a lot of fuel to work, as well as the operation of these thrusters are very short. In contrast, plasma thruster, which is projected to have many new discovery in the coming years, this is due in part by the technologies being untouched for the last few decades. Unlike combustion thrusters, plasma thrusters are clean and give off very little waste. Plasma thruster allows for long operation and the small force that it produces can easily overtake that of combustion thruster over a period of time. This allows for shorter space travel time. In case of low Earth orbit, plasma thruster could last indefinitely due to using matter from air particles as matter to eject and solar power as a power source. So the future outlook for this technology is very promising. Plasma thruster is in fact fully used in interplanetary trips today. It even enable mission that simply could not be performed with chemical propulsion. Suited mission for plasma thruster include heavy cargo mission to the moon and Mars, journey towards asteroids and giant outer planets and their moons, as well as sending unmanned probes beyond the solar systems. Plasma propulsion has been positively evaluated and successfully employed aboard many commercial and military satellites over the past decades. The interest in plasma propulsion system is nevertheless currently taking a step forward for a few reasons. One example is the emergence of all electronic communication satellites and the recognition that the benefit of small satellite pose. And lastly, like science probe for deep space intel gathering is also a factor. Without doubt, the quality of plasma propulsion will increase in the near future. In conclusion, plasma thruster encompass a large variety of technical solutions and devices which cover a broad range of size, power, thrust, specific impulses, and efficiencies. Some thrusters have a long flight heritage and are commonly available, where others are currently prototypes under development and testing in laboratories. There are obviously no ideal or perfect electric thruster for space application. The technology must be selected according to the spacecraft design, the budget, the propulsion requirements, and the mission objectives. Primary advantage of plasma thruster system is the propellant mass economy, especially for mission with large velocity increments. Electric thrusters also offer secondary benefits like precision and variability of the thrust, restart capability, and long total operational time. Their major disadvantages are the need for complicated external power source and the low thrust density level. This last characteristic limit near planet application and make launch, ascension, and descension maneuvers unfeasible. These are a list of my references. I hope this video was very educational and you were able to learn as much as I was able to. This is the last class I have to do for my bachelor's degree. I hope that moving forward, everyone will have a wonderful holiday, and thank you for the opportunity to make this and the experience I got from doing this and the education I got. Um, have a good break.